All right, this is the review for Unit 4. Question number 1, find dy for the given values of x and dx. So the formula for dy is f prime of x dx. All right, so since f of x is equal to 6x cubed minus 9x, f prime of x is 18x squared minus 9. F prime of negative 3 is 18 times negative 3 squared minus 9, which is 153. Now dx and change in x are equivalent. So this is going to be 153. Is that right? 153 times 0.1, which gives me 15.3. All right, next question. Use a differential to approximate the expression, then use a calculator to approximate the quantity, and give the absolute value of the difference in the two results to 4 decimal places. All right, so I like to use the linear approximation, which is f of a plus f prime of a x minus a. All right, and what I want to do is I want to find something so that I can take the square root of it and it's nice and a nice pretty whole number, and also something that's really, really close to the square root of 103. So the closest one I'm going to say is 100, and I'm going to have f of x equals x to the 1/2 because I know the square root of 100. So if f of x is equal to x to the 1/2, x to the 1/2, then f prime of x is equal to 1/2 x to the negative 1/2. F prime of a, or in our case, f prime of 100, is 1/2 square roots of 100, which is 1/20. F of 100 is the square root of 100. Let me move this down. Which is 10. So then what I want to find is L of 103. That's what we're looking for, the square root of 103. And it equals f of a, and our f of a is 10, plus f prime of a, and f prime of a was 1/20. X, our x is 103, minus a, which is 100. So I have 10 plus 3/20, which gives me 10.5. All right, the rest of it you can do on the calculator. All right, this is a similar question. It says use the differential to approximate the expression. I'm again going to use the linear approximation, f prime of a plus f of a plus f prime of a x minus a. The function I'm going to use is natural log of x, and the closest to 0.92 would be 1 because I know the natural log of 1 is 0. So I'm going to use a to be exactly 1. So f prime of x is 1/x. F prime of a is 1/1, which is 1. F of a is natural log of 1, which is 0. So my linear approximation is 0 plus 1, x, which is 0.92, minus 1, negative 0.08. All right, next question. Evaluate the following indefinite integral. I'm going to rewrite this integral as square root of e times x to the negative 4 plus e x to the 1/2. All right, I'm going to add 1 to my exponent and divide, so I'm going to get -3. So square root of e x to the -3 over -3. Plus, if I add 1 to 1/2, I get 3/2. I divide by 3/2. And I don't want fractions so within fractions, so I'm going to multiply by that reciprocal. So that's going to be 2e x to the 3/2 over 3 plus my constant. All right, find the equation of the curve whose tangent line has a slope of f prime of x, given that the point -1, -6. So this tells me that f of -1 equals -6. I know that my function is going to be the integral of f prime of x. And f prime of x is 4x to the -4/5. So I'm going to add 1, which gives me a 1/5. And divide by that 1/5 plus a constant multiplied by the reciprocal, and I get 20x to the 1/5 plus c. All right, that's what f of x is. Now I want to figure out what that constant is. So again, we said that f of -1, if we plug in -1, I have 20, -1 to the 1/5 plus c equals -6. So that's -20 plus c equals -6. I'm going to add 20 to both sides, and I get my constant equal to 14. So f of x is exactly 20x to the 1/5 plus 14. All right, next question is use substitution, find the indefinite integral. I'm going to let u equal 9z squared plus 2. Then du is 18z dz. I have z, not 18z, so I'm going to divide both sides by 18. And I'm going to rewrite my integral as 1 over 18 u to the 1/2 du. All right, I'm going to add 1, which gives me 3/2 multiplied by the reciprocal. 2/3 u to the 3/2 plus my constant. 1 over 27, plug back in my u, 9z squared plus 2 plus c. I forgot my exponent, 3/2. There we go. All right, next question is also use substitution to find the indefinite integral. So I'm going to let u be what's in the denominator because it's 1 degree higher than the numerator. X to the 4th plus 4x squared minus 5. Then du equals 4x cubed plus 8x dx. I'm going to factor out a 4 because that gives me x cubed plus 2x. And that's what's in our numerator. So now I'm going to divide by 1/4. So I have a 1/4 du equals x cubed plus 2x dx. Rewrite my integral, and I have a 1/4 1 over u du. The integral of that is the natural log of the absolute value of u. Plug back in my u, and I get an x to the 4th plus 4x squared minus 5 plus constant. All right, now this is one of those special ones where the substitution is a little bit different, where you have to solve for x in terms of u. So I'm going to let u be what's underneath the square root, which is x plus 8. Then du is 1 dx. And x is equal to u minus 8. So I'm going to rewrite the integral. So the top is x, which is u minus 8, over u to the 1/2. I'm going to separate this into 2 separate fractions. so that I have u over u to the 1/2 minus 8 over u to the 1/2. If I have 1 in the numerator, 1/2 in the denominator, that gives me a total of 1/2 in the numerator. And so I'm just going to rewrite the integral like this. Now I'm ready to integrate. U to the 1/2 is going to give me u to the 3/2 divided by 3/2. And u to the 1/2 is going to give me, or u to the negative 1/2 is going to give me u to the 1/2 divided by 1/2. Now let's multiply by the reciprocals and plug back in our u. X plus 8 to the 3/2 minus 16 x plus 8 to the 1/2 plus c. All right. Next question, approximate the area under the graph and above the x-axis with rectangles using the following methods with n equal to 4. So I have negative x squared plus 5. It's not necessary to know what this looks like, but I like to draw it. So this is an upside down parabola shifted up 5. So it looks like this. And it's going to hit here at what? Negative square root of 5 and positive square root of 5. And they want it from -2 to 2. And we want 4. We want 4 different subintervals. All right. So if I start with the left endpoint, remember what we're going to do is we're going to find I equals 1 up to 4 f of xi, change in x. Our change in x, remember, is b minus a over n. So my b is 2, my a is -2, and divided by 4. So I get 4 over 4, which is 1, which is convenient. All right, so my change in x is 1, and then I'm going to find, I'm going to plug in my heights using the left endpoint. So if it's the left endpoint, it's going to be this one, this one, this one, this one. All right, so my area is approximately the change in x, which is 1, times f of -2 plus f of -1 plus f of 0 plus f of 1. All right, so if I plug in f of -2, I get -2 squared, -4 plus 5, so I get a 1, plus f of -1, which gives me 4, plus f of 0, which gives me 5, plus f of 1, which gives me also 4. So I have a 9 plus 5, which is 14. So that's part A. Part B says use the right endpoints. So that means I'm going to use this point, this point, this point, and this point. Again, the change in x is still 1. F of -1 plus f of 0 plus f of 1 plus f of 2, which gives me 4 plus 5 plus 4 plus, if I plug in 2, again, I get 1, which again gives me 14. They said average the answers in part A and B. Well, since they're both 14, then the average is going to be 14. And then lastly, they want us to find the area approximated by using the midpoint. All right, so the midpoint, so you want to think about your x values being here, 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 and here. So let me make a little bit more room. Again, my change in x is exactly the same. So 1 times f of negative 3/2 plus f of negative 1/2 plus f of 1/2 plus f of 3/2. All right, and when I plug that in, negative 3/2, that gives me negative 9/4 plus 5 plus 1/4 plus 5 plus, whoops, not 1/4, negative 1/4 plus another negative 1/4 plus 5 minus 9/4 plus 5. All right, so if I count all my 5s, I get 20. And then I have negative 9/4, negative 1, negative 1, and negative 9. So let's see, that is negative 24, which is 5. So I get 15. All right, next question is find the exact value of the integral using formulas from geometry. So instead of integrating, we're going to see what it looks like and then find the area. Well, this tells me y equals the square root of 36 minus x squared. Notice y is always positive because I have a positive square root of 36 minus x squared. I'm going to square both sides. And that gives me x squared plus y squared equals 36. Now this is a circle centered at 0, 0 with radius 6. All right, but remember our y is positive. So that means it's this part of the circle, but they only want us to integrate from 0 to 6. So it's just this part of the circle. So it's 1/4 of a circle. And the area is going to be 1/4 pi r squared. And our r is 6. So 36 divided by 4, and we get 9 pi. All right, next question. Evaluate the definite integral. So this is going to be a definite integral that we're going to do with a u substitution. So let's let u equal what's underneath the square root. Then du is 4/3 x to the 1/3, whoops, dx. All right, so I'm going to multiply both sides by 3 so that I get 3 du equals 4x to the 1/3. I don't have 4, I have 20, so I'm going to multiply by 5. So 15 du equals 20x to the 1/3 dx. All right, and remember that these limits of integration are limits of integration for x, not u. So what I'm going to do is I'm going to write it as x equals 0, x equals 8. I have a 15 here on the outside and u to the 1/2 du. So let's go ahead and integrate, and I get u to the 3/2. Let's multiply by the reciprocal of 3/2, which is 2/3. From x equals 0 to x equals 8. 3 goes into 15 5 times, so I get a 10, plug back in my u, x to the 4/3 plus 9, from x equals 0 to x equals 8. All right. So let's plug in 8 first, so 8 to the 4/3 plus 9, oops, to the 3/2. Minus 10, 0 to the 4/3 plus 9 to the 3/2. All right, so 8 to the 4/3 means take the cubed root and raise it to the 4th power. So that is, the cubed root is 2, raise it to the 4th power is 16. If I add 9 to it, that gives me 25. All right, now 0 to the 4/3 is just 0. If I take 9 to the 3/2, That means take the square root of 9, which is 3, and cube it, which is 27. Do the same thing with 25. I take the square root of that, and I get 5, raise it to the third power, and I get 125. And I end up with, let's see if I have the number here somewhere. Oh, they give it to me, 960. All right, or 980, sorry. And I believe this is our last one. It says use the definite integral to find the area, total area, not net area. Remember, net area, you get the net area when you just have the integral. Between the x-axis and f of x over the indicated interval, check first to see if the graph crosses the x-axis in a given interval. So what I have is I have 32 minus 2x squared from 0 to 7. All right, and again, 32 minus 2x squared is an upside down parabola, shifted up 32, so it looks something like this. All right, now what we need to do is figure out where it crosses the x-axis. So if I let f of x equals 0, I have 32 minus 2x squared, or 2x squared equals 32, or x squared equals 16. So x equals plus or minus 4. All right, so this is at 4 and this is at negative 4. All right, but we want to integrate from 0 to 7. So that means part of this is going to be below the x-axis. So I want to find the total area of this region and this region. All right, now the integral is going to give me something negative for below the x-axis. So I'm going to have to take the absolute value of it. So above the x-axis is between 0 and 4 of 32 minus 2x squared. Then plus the absolute value from 4 to 7. All right, so let's integrate. We get 32x minus 2/3 x cubed plus the absolute value of, from 0 to 4. 32x minus 2/3 x cubed from 4 to 7. And now let's plug in. I have 32 times 4 minus 2/3 times 4 cubed minus 0 plus 32 times 7 minus 2/3 times 7 cubed minus, still in the absolute value, 2/3 4 cubed, whoops, forgot the first term, 32 times 4 minus 2/3 4 cubed. All right, what I end up with is 354 over 3. Everything I'm going to have with a common denominator of 3 minus 128 over 3. And what I end up inside the absolute value is negative 270 over 3. And I'm going to have to put it over here because I'm out of room. But you should get 526 over 3. All right, and that is the last one. Good luck to everyone taking the final and have a great summer break.